If n is equal to the set 1, 2, 3, 4 and continues, and S is the set all x such that x is equal to 2n minus 1, where n is the natural numbers, and t is equal to x such that x is equal to 2n, where n is a natural number, and v is equal to x such that x is equal to 2n plus 1, where n is equal to 0 or n is a natural number. Now we want to find the simplest possible expression for each of the following. Okay, so we want to find S union V, S union T, and S intersection T. Okay, now the union of set S and set V, symbolized by S union V, is the set containing all elements that are members of set S or of set V or both sets. Now we want to first find the elements of S. And so the definition of S is that all of x such that x is equal to 2n minus 1, where n is a natural number. So let's put in the first values to complete that sentence there. So if we let n equal 1 for the first natural number, then we would plug that in. We would say x, which is equal to 2n, or in this case, 2 times 1 minus 1. Well, that gives us 2 minus 1, which is equal to 1. Okay, if we say n is equal to 2, so we would have x, which is equal to 2 times 2 minus 1, which is equal to 4 minus 1, which is equal to 3. And then if n is equal to 3, we would say x, which is equal to 2 times 3 minus 1, which is equal to 6 minus 1, which gives us 5. And then if we put in 4, where n is equal to 4, then x is going to equal 2 times 4 minus 1. So that's 8 minus 1, which is equal to 7. So you can see here, by substituting the values of 1, 2, 3, and 4 for n, the first 4 elements of S are going to be 1, 3, 5, and 7. Therefore, we would say S is composed of the odd natural numbers. Okay, so now it says second, we want to find the elements of V. Now the definition of V is all of x such that x is equal to 2n plus 1, where n is equal to 0, or n is a natural number. So since one of them is a 0, we need to make sure that we include that. So we're going to say, okay, n is going to equal 0. And now we're going to plug it into this form. So that means x is going to equal 2 times 0 plus 1, which is equal to 0 plus 1, which is equal to 1. Now we're going to start with the natural numbers of 1. Therefore, x is going to equal 2 times 1 plus 1. And therefore, 2 plus 1 is going to give us 3. And then if we put in n is equal to 2, we have x, which is equal to 2 times 2 plus 1. And that's equal to 4 plus 1, which gives us 5. And then if we plug in the value for 3, we get x, which is equal to 2 times 3 plus 1, which is equal to 6 plus 1, which gives us 7. So you can see here that substituting now 0, 1, 2, and 3 for n, the first 4 elements are also 1, 3, 5, and 7. Therefore, V is also composed of the odd natural numbers. And because of that, we would say the following. We would say, therefore, S and V contain the same numbers, they are the same, and their union, S union V, can be written in the simplest form as either S or V. So we can say that S union V can either equal, and let me rewrite that again and make a better V. So S union V can either be S or the set V, because that is the set of the odd natural numbers. Okay, next, in part B, it says that the union of set S and set T, symbolized by S union T, is the set containing all the elements that are members of the set S or of the set T or both sets. Now, from before, the set S contains the odd natural numbers. So, remember that it contains the odd natural numbers. And that means that what we found from the previous step up here, 1, 3, 5, and 7. Now we want to find the elements of T. The definition of T is that the set of T is all x such that x is equal to 2n, where n is a natural number. So let's go ahead and substitute. So if we substitute like n is equal to 1 into this form here, x is equal to 2n, so x is going to equal 2 times 1, which is equal to 2. If we plug in n is equal to 2, we would say that x equals 2 times 2 is going to give us 4. If we plug in 3, we get x, which is equal to 2 times 3, which gives us 6. And if we let n equal 4, then we get x, which is equal to 2 times 4, which is equal to 8. So you can see here the first 4 elements are going to be 2, 4, 6, and 8. Therefore, T is composed of the even natural numbers. So we would say that the set S contains the odd natural numbers, and the set T contains the even natural numbers. So what do they contain? Well, we know that S contains 1, T contains 2. S contains the odd number 3, and then T contains the even number 4, and so on. So this is actually the set of the natural numbers. So we would say the following. We would say that S union T is equal to the set of natural numbers. Okay, now it says the intersection of S and T is symbolized by S intersection T is the set containing all elements that are members of both set S and T. Well, remember that S is equal to the set of the odd numbers, which is 1, 3, 5, and so on. And the set T were the set of the even numbers, 2, 4, 6, and so on. So what this basically is asking is, do either of these sets have something in common? Well, they don't, because set S has the odd numbers, set T has the even numbers. If they did have something in common, then that would be the intersection. But again, remember that set S contains the odd natural numbers and T contains the even natural numbers. So there are no common elements between the two sets, and therefore the sets are disjoint. So we would say that S intersect T is then going to equal the empty set. Or we can also denote it as braces with the nothing inside.